Write down the Newton's law for the box. So it's something like this. You have an inclined plane. The angle is 30 degrees, A, and the box is lies down like this. Okay. And we want to write down the Newton's second law for this object. So again, let's try to identify all the possible forces. How many forces you have in this case? Still 3 is frictionless. And in fact, there are the 3 forces here. Huh? Is it 3?
No, only 2.
Okay, think about it. It's not 3.
Only 2, right?
I didn't say there is some external pulling, right? Only 2, the weight and the normal force. Okay, it can slide down by itself. It doesn't require any pulling force. So the weight in this case is still downward, right? This is W. And the normal force in this case, please note that it's normal to the supporting ground. So in this case, it's like this. Okay? Normal force may not be vertical. In this case, it's vertical because it's normal to the horizontal ground. In this case, it's normal to the inclined plane, so it's in this direction. Okay? Normal force is down this direction. Okay? Now, the next thing is to do vector decomposition to find all the x component, the y component, so we can write down the Newton's second law. Okay? First, let's check if we do this. This is y direction, this is x direction. Let's decompose the force. In this case, which force has to be decomposed?
Normal.
The normal force A, right? So you get this is Ny. This is Nx. Okay. If you want to decompose this normal force N, of course you have to know some angle here, right? And it's not directly given, but some angle here can be figured out from this angle. Can you see that if this angle is 30 degrees, then this angle is also 30 degrees, right? Okay, that's something from your geometry, right? If this is perpendicular to this is perpendicular to this, so this angle is the same as this angle. Okay, so if this is 30 degrees, let's decompose N. So Nx equals to what?
The sine.
Okay, if this
30.
is 30 degrees, Nx is this, which is this, opposite to the given angle. So it's sine N multiplied by sine 30 degrees. Positive or negative in this coordinate?
Sine is negative. No.
Negative, right? In those coordinates. If I still use the normal coordinate, positive to this direction. And what is Ny? N multiplied by cosine 30 degrees. Positive or negative? Positive. And what is Wx? 0. Okay. What is Wy? What? Negative mg. Right? Question?
How is that negative sign going on?
Because I choose the coordinates like this.
Well,
But it's
couldn't you just?
second. Where is the x direction?
So it's positive to this direction, nx is to this direction. So nx is negative. Ny is positive. Wy is negative, right? Any question here? Any vector, we talk about the positive or negative, it's always relative to the coordinates you are choosing. So we are talking about the positive side and negative side in those coordinates. There is no universal way to state positive and negative without specifying the coordinates. Okay? So you may be thinking about some coordinates in your mind, but this is the coordinates I call here. So now, after decomposition, let's write down the Newton's second law. Okay? Along x direction, you have two forces. Put them together, it will give you negative n sine 30, okay, plus 0 equals to m8x. Okay? And y direction, you have this plus this, so it's n cosine 30 degree minus mg equals to m8y. Okay. So you got two equations. If you have numbers for the two equations, you should be able to solve other coordinates. Okay. One comment I would like to add here is, by looking at these equations, you probably have a better understanding between the difference of G and A, okay? I remember in the first unit, some of you may get confused with where you should use G, where should you use A, okay? G is in the definition to cancel per weight. And if you have only one forces acted on the object, so it turns out when you calculate A, it will be the same as G. But in this case, when you have several different forces acted on the same object, so G is not necessarily to be the same as A. Like in this case, if you look at this term, here you have G, and here you have AY, but you still have other terms. So there is no equality between G and A. A is the actual acceleration for the motion. G is a constant. To determine the weight, they are totally different things. Okay. Now, AX and AY. In this case, do you have any information about AX and AY like this? Can you say AY equals to 0 in this case? No. Please note that the motion is like this. So the motion itself has some, so the motion is like this, so it has both the x components and y component. So the acceleration has both non-zero x component and non-zero y component. So in this problem, in this coordinate, you can only write it to this point. You cannot simplify it further because you don't have this. Okay? Any question here? But now, let's talk about choose the best coordinates. This discussion says that, okay, because the motion is along this direction, And if you make some normal coordinates, so both none of the ax nor ay will be 0. But how about if we establish some coordinates like this? I will make my positive x along the direction of motion, which is parallel to the inclined plane. And my positive y will be this direction. Okay? Now let's do the decomposition. Your w is still in this direction, n is still in this direction. Okay? The force itself, their direction is basically fixed. They are not changing with coordinates. Here you can only rotate the coordinates. Okay? So in this case, can see the force has to be decomposed is W, not N, right? So when you decompose the force, you get this is 30 degrees. Okay. You want to decompose W, so you get this is WY. And this is Wx. You want to get Wx and Wy, right? Okay. So if this is 30 degrees, can you identify that this is 30 degrees? Right? Okay, because this is perpendicular to this. This is perpendicular to this is perpendicular to this. So this angle must be the same as this angle. Okay? Another way to check is looking at this triangle and this triangle. This plus this equals to 90 degrees. This plus this equals to 90 degrees. But this equals to this. So this equals to this. Now, okay, let's write down the expression for nx in this coordinate. What is nx and ny? What is nx?
This is a W sign.
Nx, normal force.
Oh, N?
Nx, n,
Oh,
0.
0. And ny equals to n, right? In this coordinate. And then wx in this coordinate, how do you express wx?
W sine 30?
W, which is mg.
Negative, yeah.
So mg multiplied by sine 30, positive or negative?
That's negative.
In those coordinates, it's positive, right?
Oh,
Okay, because positive is here. And what is wy?
mg cosine
mg
30?
cosine, okay? Negative mg cosine 30 degrees. Okay? We check these expressions. Do you have any question about whatever sine, cosine, or positive, negative? Okay. So if you have a question, let's write down the Newton's second law in this situation, in this coordinate. Okay? In this coordinates, the Newton's second law along x direction, along y direction should be, along x direction should be x direction is this plus this, right? So you get 0 plus mg sine 30 degree equals to m ax, and along y direction you get this plus this, including the sine. So you get n minus mg cosine 30 degree equals to may. So for the same problem, now you see you get two different set of equations, completely different. It totally depends on your choice of the coordinates. And this AX is not the same as this AX. This AY is not the same as this AY, right? When you do this direction, AX and AY will be the acceleration along this X direction, this direction, Y direction. In this case, this AX and this AY will be the acceleration along this direction and this direction. You are decomposing them into different coordinates. Okay. Any question here? Okay. I know usually when the problem you can have different way to do it, or sometimes you may get confused. So you have to understand this very well, the decomposition procedure. You cannot mix the two different decomposition together. Okay. So one of the important things you need to compare similar things and see what's the difference between similar things. Okay. Like in your in your test, do you have some problem with projectile motion? Okay. Do we have a girl kicks soccer ball? I think we do.
Yeah, we do.
Yes.
And remember, we have two problems related to girl kicks a soccer ball. One problem is from the initial point to the landing point. One problem is from initial point to the highest point. Okay? It always happens that when we ask one problem, a student may solve the other problem. Okay? So you need to think about what you are actually doing there. You cannot just say, oh, this is a girl kicks a soccer ball. Okay, let me do what it's already in my mind. A girl can kick a soccer ball in many different ways. Okay. So here, you can see, okay, this, in principle, you can do this and this. Okay, both are correct. But this one is better than that one. The reason is that now if you look at the AX and AY here, okay? Now, can you see this AY equals to 0? Yes, in this case it is, because A is along this direction, so it has only X component. It doesn't have any Y component in this coordinate. Okay? So in those coordinates, AX equals to A and AY equals to 0. It's only true if you are decomposing it in this way. And it will not be true if you are decomposing it in this way. Okay, so any problem you have to choose an appropriate way to decompose it. So of course, if you have this one, then the two equations can be simplified as mg sine 30 equals to ma, and n minus mg cosine 30 equals to 0. Dy equals to 0, right? So that's why I say this is a better way to decompose it for this problem, because you can simplify it further, like this. But for this equation, you cannot simplify it anymore. Okay? So you can see here, the trick is that you always try to make one of your axes along the direction of the motion, right? So in that case, you have only one component for acceleration. Okay. So here, if the motion is horizontally, you make some horizontal x-axis. If the motion is not horizontal, then you make some concave coordinates.